Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 9 of a unit current electricity. So let's begin with today's class. In today's class we are going to discuss about the Kirchhoff's law. Basically there are two laws that Kirchhoff has given. One is known as Kirchhoff's current law. It is Kirchhoff's current law. In a short, we call it as a KCL, and another it's a Kirchhoff's voltage law. We call this as a KVL. So these two laws are there. It's a KCL and KVL, and we are going to discuss about this. So let's begin with the Kirchhoff's current law. Let's begin with the KCL. Now before we move to the KCL, let's look out certain terminology. One very important terminology is of junction. Now what we call as a junction. Let's suppose see this diagram. Consider a road as shown. That we can see that at this point more than two roads are connected with each other. So this is the diagram where four roads are meeting at a certain point. Yes. So let's suppose this is the point, and one of the way is coming from here, another 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 way is coming from here, and they all meeting up at here. So it what we call a junction, it is the point where more than one point is going to be merged, or we can say it's an any point in the circuit where the current can split or can be added up. This point is called as a junction. Yes. So it is the location at which more than one currents or more than two currents are being combined or getting splitted. That location in the circuit can be said as a junction. I hope these things are clear. Okay, why we are discussing about the junction? Yes, because KCL is all about the junction. Now let's look at this situation. This is the junction that I know. Now look at this currents. I1 is the incoming current, I2 is the incoming current, and let's suppose I1 and I2 as well as I4. This all are incoming current. When we say incoming current, that means this currents are moving towards the junction, and outgoing currents, it's an I3 and I5. So I3 and I5 are outgoing current. That means this are the currents. They are moving outside the junction. So these are the incoming currents and these are the outgoing currents. Now according to the sign convention of the Kirchhoff's law, let's suppose we are assuming that all the incoming currents is to be taken as a positive and all the outgoing currents are taken as a negative. You can take any convention of your choice. There is no boundaries or there is no restriction on it. But let's suppose I have chosen that all the incoming currents is to be considered as a positive and all outgoing current is to be considered as a negative. So what can I write according to the Kirchhoff's law? According to the Kirchhoff's law, it states that total incoming current is equal to the total outgoing current. So I have considered this incoming currents as a positive and outgoing current as a negative, and we say that total incoming current and total outgoing current will be equal. So when we say incoming current, according to this diagram, it's an I1, I2 and I4. So I have written I1 plus I4 plus I2. That should be equals to I3 and I5 because these two are the outgoing current. Yes, is it clear? Is it? Any doubts? Any doubts? Is there anything? No? Great. So according to the KCL, total incoming current for the junction is equal to the total outgoing current. This is first law of Kirchhoff. It's a KCL. One more relevant result will be, or alternating form of Kirchhoff's current law is algebraic sum of the currents at a junction is zero. That means if you observe this at junction and you are going to add every currents according to their sign convention that we have decided is always zero, but this is applicable at junction only. So if I observe this at junction, incoming current to be considered as in positive, I1, I2 and I4. This three are the positive. I3 and I5, these two are the negative, minus I3 minus I5, and that would be equals to 0. It is the same thing. If you are going to solve this, it's an I1 plus I2 plus I4. That should be is equals to I3 plus I5. This was the situation in the previous slides. So this are one or the other way to represent the things. So whatever you remember, whether you can do that at the junction I am going to add everything with sign convention and make it zero, it is absolutely okay. Or you are considering that I will supposed to have all incoming currents, that should be equals to all outgoing currents. Both are saying the same thing, but you must ensure that this is the point where you are applying KCL, that must be in junction. And for junction, it is the point or it is the location at which more than two currents are meeting up or splitting up. Yes, if it is not the situation, we cannot apply KCL. I hope these things are clear. It is great. Let's look at the question. Kirchhoff's law of junction is in accordance with the law of conservation of. This is KCL is in conservation of. It is conserving charge. Yes, it is conserving current as well, but it is not conserving energy. So this is incorrect. These two are correct. This should be the answer. Please do remember this. KCL, it's a Kirchhoff's current law, is in accordance with the state of its a charge. That means conservation of charge and conservation of current. Now one more. Kirchhoff's law of junction is also called the law of conservation of charge. Yes, total charge that is coming, this total charge are going to living. Yes, when we say we are delivering incoming current or we are having an outgoing current, that means we are having an incoming charge and we are sending the outgoing charge. So it is also called as the law of conservation of charge. This was all about KCL. We are going to learn and we are going to practice some questions based on it. But before we go, let's understand what is Kirchhoff's voltage law. It's a KVL. So let's look what is KVL is all about. According to the Kirchhoff's voltage law, it states that algebraic sum of potential differences of all components and sources of EMF is equals to 0. Now what does it mean? It says algebraic sum of potential difference of all components. That means sigma IR. We know that V is equals to IR. So it's a potential drop across resistance. It's a I into R. So that is algebraic sum of this. It's a sigma IR. And sources of EMF, it is a sigma E. If we add this two, then it must be in 0. Yes, I hope these things are clear. Now let's look at certain rules and convention needed to do this. So before we begin, let's understand that what are the procedure or what are the conventions to be taken for the KVL. First, when we move from one point to another, in the same direction as direction of current, then we take IR as positive and if we move in opposite direction, if we move in opposite direction to the current, take IR as negative. One thing, yes, when we considered IR as a positive and when to consider IR as a negative, if we are moving in the same direction as direction of current, then we take I into R. It's an algebraic sum of the potential difference across the resistor. It's an I into R as a positive, and if we move in the opposite direction, then we take IR as a negative. Second thing, KVL can be applicable to closed path only. KVL can be applicable to closed path only. Yes. And what about the voltage sources? What about the voltage sources? We know that about the voltage sources, if we are moving from one point to another and we stuck with a battery's positive terminal, we consider it as a positive, and if we stuck with the negative terminal of the battery, we are considering it as a negative. I hope these things are clear. Is it? So let's practice this with the help of question only. Let's have a look. First, observe this diagram very carefully. Here, for your help, I have mentioned the currents as well, but when you are practicing this, only the circuits would be there, and current direction as well as current's value you need to consider. So let's begin then. What is the situation? That let's suppose that we are having two loops. This is the first loop. When I say loop, I mean loop is any closed path of circuit. Please remember, this is the closed path of any circuit. So when we say we are taking this loop, that must be a closed loop. That cannot be an open path. If it is an open path, we cannot apply KVL to it. It must be a closed path to be taken. Yes, so if we take if we consider loop, it must be a closed path of the circuit. So let's suppose this is loop 1 and the second, this is loop 2. Yes, always try to remember that, always give the symbolic name, just as A, B, C, D, E, F to the loop. Yes, this will help us. Now this is the situation where in first loop, let's suppose a source is of E1, and from E1 certain current is moving, it's an I1. Now the I1 will move in this direction, it is moving in this direction. From here it is the I1 that is moving in this direction, and from branch 2, from it's a positive terminal of the battery, so from here I2 is moving and it is joining at here. So at this point two currents are merging up. The first one is of I1, the another one is of I2, and from R3 two currents are moving, it's an I1 plus I2, and at it reaches the point C, as I1 and I2 is reaching the point C, I1 is moving in this direction and I2 is moving in this direction. So I2 will continue to move in this direction and I2 will be available here, and I1 is moving in this direction. I1 is moving in this direction and it is available at this point. So always you need to understand that whatever the amount of current that has been left from any of the source, if the same amount of current is coming back to the source, that means you have divided current in an appropriate manner. I repeat, whatever the amount of current that is leaving from the source, let's take an example of E2. From E2 current I2 is leaving. So if after passing through loops and all that situation, if current I2 is coming back to the E2, that means you have divided your current appropriately. If it is not the case, you made a mistake at some of the place. So if current is not coming back same current, then you need to observe your current distribution again. Yes, so let's try to write down the relation according to the KVL. Now let's suppose first take loop number 1. We are moving from A, D, C, B, A. Look at this. We have started with the A and we are ending with the A. So it is closed loop. So when we are moving from A to D, it is the resistance that is coming, and I am moving in the same direction as direction of current. So it would be an I1 multiplied by R2. Then I am moving from D to C. From D to C, here there are two currents, I1 and I2, and resistor is there. So this is plus I1 plus I2 multiplied by R3. From C to B, no component, only current is leaving. From C to this position, from B to this position, only the current I1 is leaving. It's I1 R1. Then you are moving towards the minus of E1 because you're stuck with an battery negative terminal, and you have reached to the A. That means this is equals to 0. I hope these things are clear. So if you wish, you can solve this. It's an I1 R2 plus I1 R3 plus I2 R3 plus I1 R1, and that should be equals to even. This is relation number 1. Yes, in loop A, D, C, B, A. This is the case. Now let's look at the second loop. This is my second loop, and let me write the relation from here. It's a loop of D to C to E to F to D. It's a D, C, E, F, D. So let's begin from D to C. Here the current was I2 plus I1. So this is I1 plus I2 multiplied by R3. Then from here to here, nothing to be written. From here it's an I2 that is moving. So plus I2 into R5 minus of E2, that should be equals to 0. So this is the case where you are going to write I1 R3 plus I2 R3 plus I2 R5, and that should be is equals to E2. This is relation number 2. Now you have two relations. This is relation number 2, this is relation number 1 that we have written in the previous slide. We have two unknowns. Look at this. All these values can be given. E1 would be given, E2 would be given, and only the two unknowns would be there. One is the I1, another is the I2. So what you need to do, you have two relations. This is first and this is second. So two relations are there, two unknowns are there. You can solve it and get I1 and I2 after solving 1 and 2. This is to be done. Yes, always remember one very important aspect is you can get value of n number of terms if you have n number of relations. Yes, so always remember this thing, that if you have three unknowns, that means you must be having three relations. If you are having two relations but you are not if you are having two relations but you are having three unknowns, that means your task will not be performed. You cannot get the three values, definitely not. But if you require a two values and you are having a three relations, it is more than enough. The situation is more than enough. You are going to have your answer. I hope these things are clear. Is it clear? So if you are having three unknowns, you must have at least three relations. If you are having five unknowns, you must have at least five relations. I hope these things are clear. Is it clear? Great. Now let's suppose practice the question. Look at the diagram first. Let's suppose I have been given that find out current I1 and I2. So basically, if you observe the situation, that this is the battery of 10 volt and current must be leaving from this in this direction, and I have symbolized it as an I1. Here it is a battery of 20 volt and total current I is leaving from this. The total current whatever is coming at point C, it has been divided into two segments. It's an I1 and I2. I2 is moving in this path. I1 we have already seen. It's at this point D. At this point D, two currents. It's an I1 and I2 that is getting merged, and from here it's a I that is coming. So from 20 volt I was leaving and we have an I, and from 10 volt I1 was leaving and we are having an I1. That means we have distributed our current appropriately and there is nothing wrong in it. Now one more thing, what do we require? We require three things, I1 and I2, but how many unknowns are there? Basically what I can observe at point D is I1 is the incoming current, 4 point D, I2 is the incoming current, and that is equals to outgoing current. So I1 plus I2 is equals to I. So what I understand is this is the first unknown and this is the second unknown. If we are able to solve for this two values, if we are able to solve for this values I1 and I2, we can easily get I. It is just the summation of this. So at least we must have two relations, and if I am having the two relations, I can get it done. I hope these things are clear. Is it? So let's take this as a first loop and try to write down the relations. So if I take a loop that is from O, A, B, D and again back to O, it's a O, A, B, D, O. So let's write it down. From O to A, it's a minus of 10 because it is a battery's negative terminal. From A to B, nothing. From B to D, nothing to be right. And from D to O, it is the current I2 that is moving, but current is moving in this direction and I need to move in this direction, so I need to write down the minus. It's a minus of 2 into I2, it's a I into R, and that should be equals to 0. So this is minus of 10 should be equals to 2 into I2, and I2 should be is equals to minus of 5 ampere. This is the value of I2. That is of minus of 5 ampere. I hope these things are clear. Is it clear? Now let's write it down, the relation for second loop. This is my second loop. So for this loop, for loop, let's suppose I take C, D, E, F, G and C. So we are moving in this direction, C, D, E, F, G to C. Yes. So if I'm moving in this direction, let's write it down. Here it is an I2 that has been passed through the 2 ohm. So this is 2 into I2. From D to E, it is the I which is flowing, and when I say I, it is the combination of I1 plus I2. I know that this is I, that should be equals to I1 plus I2, and we are moving in the same direction as current is moving. So we are going to write plus 5 I1 plus I2. Then from E to F, nothing to be written. From here, it's an I that has been moving through 3 ohm, plus 3 into bracket I1 plus I2. Then it's a minus of 20 because you stuck with the negative terminal of the battery, and that should be equals to 0. So this can be written as 2I2 plus 5I1, 3I1. It's an 8I1. 5I2 plus 3I2 plus 8I2 equals to 20. Now you are having a value of I2 that is of minus of 5 ampere. So this is 2 into minus of 5 plus 8 into I1 plus 8 into minus of 5, that should be equals to 20. So this is minus of 10 plus 8 I1 minus of 40 equals to 20. So that can be written as 8 I1 equals to 20 plus 40, 60, 60 plus 10, it's a 70, and I1 is equals to 70 by 8, or you can write this as a 35 by 4 ampere. So now you are having an I1, you are having an I2, so you can get it done for the I. Now one more query is, do we have current in negative? Do we? Can we have a value of an current in negative? If not, then why this is negative? What is the situation is that we have assumed that direction of current is from C to D, and according to our assumption, current was minus of 5 ampere. That means in reality, current I2 is flowing from D to C. This is what it represents, that because at the initial position, at the initial point, when I don't know the values, I don't know the loops, I'm just dividing the currents, I just go with the flow. That means that this is the master battery. From here current should be moving, wherein when a junction came, I'm going to divide the current and I will just go with the flow. But if the current is in negative, if the current arrives in a negative, it means I have shown the opposite direction of that current. It is nothing wrong in it. Nothing is wrong in it. Yes, you need to just assume that, or you can have a note if you are attempting the subjective examinations such as the board examinations, that in reality current is flowing from this to this, and I assume this direction, that's why my current is negative. That's it. I hope these things are clear. Yes. So ready for the next question? Are you ready? Let's have a look. The next question. What does it says? That a circuit diagram is given, and this is of 8-volt battery. A current is living from here. The total current I is living. From I, the current when it reaches at C, I have divided into two segments again. It's an I1, it's an I2. I1 is moving in this direction, I2 is moving in this direction, and at point F it is again going to be meet up. It's an I1, it's an I2, and from here again current I would be there. So I has been living and I have been available. So I have divided the current in an appropriate manner. Now the question says find out I1 and I2. So now you understand that, let's suppose at point C I is the incoming current and I1 and I2, these two are the outgoing current. So basically you require I1 and I2. Once you get this, you can easily have an I. So let's begin then. Let's take first loop. Suppose this is the first loop, starting from A to F to C to B to A. It's an A, F, C, B, A. Let's write down. From A to F, nothing to be written. From F to C, current is moving in this direction. We are moving in this direction. So please be cautious. I need to write minus of I. Yes. So this is minus of 4 into I1. Then minus of 1 into I1. Then positive terminal of the battery, it's a plus 5. Then from here to here, nothing to be written. From B to A, the current is moving in this direction, even I am moving in this direction, so this is plus. It's a 3I2 and that should be equals to 0. So this is minus 4I1, this is minus of 5I1, this is minus of 5I1 plus 3I2 should be equals to minus of 5. So if I multiply this with the minus, it's a minus of 5I1 minus of 3I2 equals to plus 5. This is the first relation. Is it clear? Is it clear? Now let me write one more loop. It is, let's say, suppose we are taking the second loop of this. It's an F. It's an F, E, D, C and F, starting from here ending up at here. So from F to E, nothing to be written. Next it's a minus of 8 volt. Then it's a 1 ohm, but here total current I is flowing, and when I say I mean it's an I1 plus I2 is flowing. So plus I1 plus I2 multiplied by 1. Then here it's a 2 ohm, again I1 plus I2 multiplied by 2. Then from here, from C to in this direction, F, E, T, C. Here current I1 is flowing and negative terminal of the battery is there, it's a minus of 5. Then we are moving with 1 ohm, it's a plus I1 into 1 because we are moving in the same direction, plus 4 into I1, and that should be equals to 0. So trying to get it done, it's a minus 8, it's a minus 5, this is minus of 13, plus 1 into I1 plus 2 into I1, this is plus 3 into I1, plus 1 into I2 plus 2 into I2, it's a 3I2, minus 5 already written, plus I1 plus 4I1, that should be equals to 0. So this is 3I1, this is I1, this is 4I1, 3 plus 1 4, 4 plus 4 8, it's an 8I1 plus 3I2, and that should be equals to 13. This is relation number 2. So we have two relations, and we have two unknowns. So let's just try to get it done. The first relation was 5I1 minus of 3I2 should be equals to 5, and the second relation was it's an 8I1 plus 3I2 should be equals to 13. If I solve this can be cancelled out. This is 5 plus 8, this is 13 of I1, that should be equals to 18. That means I1 should be equals to 18 by 13. Yes, I got the I1. Now let's put up the I1 at one of the relation and get it done. It's an 8I1 plus 3I2 should be equals to 13. So this is equals to 8 multiplied by 18 by 13 plus 3I2, that should be equals to 13. 18 8s are 144, divide by 13 plus 3I2 equals to 13. So this is 3I2, that is equals to 13 minus 144 divided by 13. It's a 13 into 13. We are taking LCM. It's a 169 minus of 144 divided by 13. So 169 minus 144, it's a 9 minus 4 5, 6 minus 4 2, and 1 minus 1 0. It's a 25 by 13, but this is 3i2. So I2 could be written as 25 by 39. Is it clear? It is 25 by 39. Now let's just check it out, the value of I would be equals to I1 plus I2. I1 is of 18 by 13. I2 is of 25 by 39. So this can be written as 18 threes are, this is 54 by 39 plus 25 by 39, and this is I, which is equals to 4 plus 5 9, 5 plus 2 7. It's a 79 by 39 ampere. So you got all this. You got I, you get I1, you get I2. I hope these things are clear. What was your answers? What was your answer? Does it same? Does it same, or it's a different one? It is great. You did it correctly. So ready for the next question? Ready? Let's have a look. Yes, this is the same question. Let's look at this question. Let's suppose find out current through 10-volt battery. Now, in the previous questions, I have already given the direction of current and distribution of current, but here I am not mentioning it, so that we need to decide the directions. So what can be done? These are just the suggestions, and these are not the things that we need to do this only, but these are the suggestions. Always choose the master battery. While I say master battery, I mean always choose a battery having greater potentials as a master battery, because there might be situation that current must be starting from here, from there, and it is going to divide it into other circuits. So look at this. This is 6 volt, this is 4 volt, this is 10 volt. So I will choose this as a master battery. Let's start the current I. It is moving in this position, and once it reaches here, it is to be distributed into two segments. Let's suppose this is an I1, this as an I2. So I1 will be moving in this fashion. This is I1 that is moving, and from this point I1 is there. From I2 is moving in this point. It's an I2 that is flowing, and as this point, these two are going to be added up. So this is I1 plus I2, which is I only. So we have distributed the current. Our first task has been done. I hope these things are clear. Is it? Now next task is to write down the loop. It's a, let's suppose this is A, this is B, this is C, this is D. So loop has been written, and it has given the notations. Now start writing the relations according to the KVL. So if I write this, it's in from A, B, C, A. This is the first loop, A, B, C, A. So if we are moving from A to B, nothing to be written. From B to C, we are moving in the same direction as current is moving. So this is of 4 into I1. Then it's a positive terminal of one battery. It's a plus 6. Then from C to A again, this is minus of 10 volt of battery, and that should be equals to 0. So this is equals to 4I1 plus 6 minus 10. It's a minus of 4, should be equals to 0. And thus I1 should be equals to 4 by 4. It's 1 ampere. I hope those things are clear. Is it clear? From ABC, this is the first loop. Now I require two things. 1 and second. So let's write it down the one more loop. It is A, B, C, A. This is the second loop. It's an A, D, C, A. Current is moving in this direction. This is 2 into I2. Then it's a plus 4. Then from D to C, nothing to be written. From C to this direction, it's a minus of 10 equals to 0. So this is of 2I2 plus 4 minus 10. It's a minus of 6, and that would be equals to 0. Yes, is it clear? Is it? Great. So this is of 2I2, that is equals to 6, and I2 is equals to 6 by 2, which is 3 ampere. What was I requiring? I requiring I. So I can be written as I1 plus I2. It's a 1 ampere plus 3 ampere. It's a 1 plus 3, which should be an 4 ampere. I hope these things are clear. It is? Great. So now can you do this kind of questions? Can you? Is it possible? Great. Let's have a look to some other questions. What does it says? What does it says? It says that two cells of EMF E1 and E2 are connected to two resistors R1 and R2 as shown in the figure. It says if E2 is short circuited, this is being short circuited. So when it is short circuited, that means it must be connected with certain kind of wire, something like this. Then currents through R1 and R2, this is what we require. So if E2 has been short circuited, no current is passing through it, because as we have discussed when we were discussing the open circuit, short circuit and all that stuff, that when the situation would be of short circuit, the current is not going to pass through here, because current is having a path which is of less resistive, and it will choose that path, so it will bypass this. So currents through R2, it's an I2 equals to 0, because it's a current through R2, because this E2 is being short circuited, and I1, it is probably this current. So I1 can be written as, it's an E1 divided by R1. I1 can be written as E1 divided by R1, and I2, this would be equals to 0. I hope these things are clear. So this would be the correct answer. This is it. Every time it is not necessary to apply a KVL or KCL. It might get solved. It might get solved you with the help of very basic formulas as well. So please try to get it done. Yes, let's have another question. In the given circuit, if ammeter reads 5 ampere, here it is ammeter. What is ammeter? What does it keep for? Yes, it is there to read the current flowing through the circuit. What is the use of voltmeter? It is there to measure the potential difference across two terminals. What is potentiometer? It is there to measure an EMF that we have discussed. Yes. So in the given circuit, if ammeter reads 5 ampere, I need to calculate the EMF. I need to calculate the EMF of the cell. Okay, how could I do this? So let's suppose, look at the circuit very carefully. Suppose current I may be starting from here, divided in two parts. One is this, it's an I1. Another is this, it's an I2. So I1 would be moving in this, I1 would be moving in this, and it will be available at here. Yes, and from here a certain current is going to be added. I2 is moving in this, I2 is moving in this, and I2 would be divided into two segments. This is, let's say, I3, and let's say this is I2 minus of I3. So in this path on this path I3 would be there. On this path I1 is there, it is available at here. Here it's an I2 minus I3, and here it's an I1 plus I2 minus of I3. This is available, it is moving in this, so they are meeting at here. So at point A it's an I1 plus I2 minus of I3 plus I3, which will be I1 plus I2 is available. So I is I1 plus I2, and whatever we have delivered we have received. That means I have give it the correct notifications of the current. I hope these things are clear. Is it clear? Is it clear? Great. So what you are supposed to do, you have a three unknowns, I1, I2 and I3. You have a three unknowns, and for three unknowns you require the three relations. So how will you do it? How will you do it? Let's start doing it from, let's suppose take a first loop. It's from A, D, B, A. This is A, D, B, A. So we are starting from the A and we are reaching the A again. So from A to E it's a minus of E. So then from D to B it is the 6 ohm of resistance and current is of I1. So this is plus 6 I1. Then from B to A again, so this is equals to plus 8 into bracket. This is the current that has been flowing through this. I2 minus I3 is coming from here, I1 is coming from here, plus 8 into bracket I1 plus I2 minus I3, that should be equals to 0. So this is equals to 6 I1 plus 8 I1. It's a 14 of I1 plus 8 I2 minus of 8 I3. This is equals to E. This could be your first relation. Yes. Now let's find it out the second. Let's find it out the second relation. We are going to write the loop for D, C, B, D. It's a D, C, B, D. So this is 4 into I2. We are moving in this. Current is moving in that path only. From then it's a C to B. It is I2 minus I3, but nothing to be written. And from B to D it's a 6 ohm resistance and minus of I1 because we are moving in opposite direction. So this is 4 I1 4 I2 minus of 6 I1, that should be equals to 0. So here I got a very important relation, that is 4 I2 must be is equals to 6 I1. So this is I2 by I1, I2 by I1, this is equals to 6 by 4, which is 3 by 2. This is D, C, B, D. I hope these things are clear. Is it clear? Great. Now we have a one relation which is of I2 by I1. We have one more relation. So if you are going to put it up here, if you are going to put up the value of I2 or let's say value of an I1, you might get a certain relation which could be written like this. It is that can be written as suppose it's a 14 of I1 plus 8 into I2. Now according to this, I2 equals to 3 by 2 of I2. That's a 3 by 2 of I1 minus of 8 I3. That should be is equals to E. So if I solve this, it's a 14 I1 plus 8 3s are 24, and this is 4. It's a 4 3s are 12 I1 minus of 8 I3, and that should be equals to E. This is 14 I1 plus 12 I1. This is 26 I1 minus of 8 I3. This is equals to E. This is relation number, let's suppose 1 dash. This is 1 dash. This is relation number 2. It's a 4 I2 minus of 6 I1, and and you can solve this. It's a relation number 1, it's a relation number 2, and you will get the answer. I hope these things are clear. Is it? Is it? So can you do this? Are you sure? Can it be done? Yes. If you want, you can take one more loop. You can take one more loop so that your task may be done more easily. And that take third loop as A D C A. Take this loop. Take this loop A D C A, and your task will be done. I hope these things are clear. Can you do this, or I need to do this? Can you? Let me help you guys. Take third loop as A D C A. So from A to D, from A to D, it is of minus of E. It's a minus of E. Then from D to C, it is a 4 into I2, and we are moving in this we are moving in the same direction. So this is plus 4 into I2. Now from C to A, it is the 6 ohm of resistance, and I3 is the current. So this is plus 6I3, that should be equals to 0. So this is 6I3 plus 4I2, that is equals to E. This is, let's say, relation number 3. We already have one more relation, that is of 26I1 minus of 8I3. So this is 26I1 minus 8I3. This is 26I1 minus of 8I3. This is equals to E. This was a relation number 1 dash, and we have relation of I1 into I2 as well. It's an I2 is equals to 3 by 2 I1. I2 equals to 3 by 2 I1. So let me just change this. Let me just change this I1 with the help of I2. It's a I1 that should be equals to 2 by 3 I2. So this relation can be converted to 26 multiplied by I1. I1 is equals to 2 by 3 of I2 minus of 8 I3, that should be equals to E. So this is 26 2s are, it's a 52 I2 minus of 8 3s are 24 I3 equals to 3E. This is 3 dash. And the another relation of I2 and I3, it is 4I2 plus 6I3. This is equals to E. This is relation number 3. Now I hope you can do this. Yes, multiply this with 4. This is equals to 4E. Now again this becomes 16I2 plus 4 6 are 24I3. That should be equals to 4E plus 3E. It's a 7 of E. Sorry, it's a 4E. Yes, solve this and this. This 2 would gone. 52 plus 16, it's a 68 I2, that is equals to 7E. So you get the I2, and from I2 you get the I1, from I1 you get the I3, and onwards. Yes. So can you do this kind of question? Is it possible? Great. Let's have a look to the next question. What does it say? It says the current in the given circuit is, so they have mentioned all the things. The task is bit easier for you. It's a 2 volt and 2 ohm. That means this is the internal resistance of a circuit. It is moving in this, and this I1, one other network is there. and other source is there, it is a 1.5 volt and 2 ohm of resistance. So one more, it's an I2, and here it's a 4 ohm. So this is I have mentioned loop 1, this is I have mentioned the loop 2. For your purpose you can take 2 ohm over here and this 2 ohm over here, and then start doing it. So if you take loop number 1, let's give them a name as, suppose it's an A, B, C, D, E, F. So we are going to write a first relation for A, B, E, F, A. So from A to B, nothing to be written. From B to E, it is the 4 multiplied by I1 plus I2. From E to F, nothing to be right. And then it's a minus of 2 volt. This is minus of 2 volt. And then a resistance of 2 ohm. And the current is I1. So this is equals to minus of 2 multiplied by I1, that should be equals to 0. So this is 4I1 minus of 2I1, that is plus 2I1 plus 4I2, that should be 2 volt. This is the relation. This is the relation number 1. Now take one more loop. It's let's suppose B, E, D, C, B. Current I1 plus I2 was there. Yes, from here it has divided into I1, and from here it has divided to I2. So from B to E, it's a 4I1 plus 4I2. From E to D, nothing to be right. Then from minus of 1.5 volt, then moving in the same direction, this is of plus 2I2 should be equals to 0. So this is equals to 4I1 plus 4I2 plus 2I2, it's a 6I2, and that would be equals to 1.5 volt. I hope these things are clear. It's a 2 volt, it's a 1.5 volt. Now you are having a 2 relations and you are having a 2 unknown. I hope you can do it. Yes, great. Let's look at the last question of today's session. Let's have a look at this. What does it say? It says the given 4 terminals network is a part of larger circuit. Okay, the points A, B, C and D are at the same potential. So A, B, C, D are at the same potential, and the potential difference between any of A, B or C and D is 40 volt, and the potential difference between A and O. Okay, you require the potential difference between A and O. Now how can you do this? How can you do this? What I can assume is, what I can assume and what I can consider is that let's suppose that certain current is coming from here, it's an I1. Let's suppose this is I1. A certain current is coming from here, it's an I2. Certain current is coming from here, it's an I3, and certain current is moving from here, it's an I4. So what I can write at point O, it's considered as a junction, that all the incoming currents, which is I1 plus I2 plus I3, should be equals to I4. I hope these things are clear. Is it clear? So if I write the I1, what is it? It's a potential difference between A and O. I can write like this, it's I is equals to delta V by R. So my I1 would be equals to VA minus of V naught divided by resistance. My I2 can be written as this is VB, this is VO, it's a VB minus of VO divided by resistance R. My I3 could be written as VC minus of VO divided by R, and I4 can be written as this is VO, this is VD, so this is equals to VO minus of VD divided by resistance R. So let me put up the value. It's an I1 plus I2 plus I3 should be equals to I4, and I1 was VA minus of V0 divided by R. I2 was the VB minus VO. Yes, it's a VB minus of VO divided by R. I3, it's a VC minus VO divided by R, and I4, it's a V0 minus of VD divided by R. This has gone. So what we get, it's a VA plus VB plus VC minus of 3 V0 is equals to V0 minus of VD. So it's a VA plus VB plus VC plus VD is equals to V0 plus 3 V0. It's a 4 V0. I hope these things are clear. Is it? What I require? I require potential difference between A and O. So this is of 4 V0. This is of 4 V0. So what I can have? It's a V0 is equals to VA plus VB plus VC plus VD divided by 4. Now potential difference between A and O. Potential difference at A, what I require, it's a VA minus of V0. So that can be written as VA minus of, this is VA plus VB plus VC plus VD by 4. So this is 4 VA minus of VA, it's a 3 VA minus of VB minus of VC minus of VD divided by 4, and your task will be done. I hope those things are clear. Then put up the value, as they say that A, B, C and D is at 40 volt. Put up the value and get your answer. Is it clear? Is it? So can you do this? Great. Let's wind it up this session over here. Yes, this is all about the KCL and KVL. Mostly the situation is that certain questions that require a larger amount of time, that is generally being asked in board examinations, and very shorter kind of questions, that means like a junction rule or shorter loops, just as 1 or 2 loops would be there, and the answer can be done, and it can be get it done within probably 1 or 1.5 minutes. That has been asked in the competitive examinations. So what you need to do is just practice at least 50 to 60 questions at least in a one day, and do the same practice for 2 more days. That means at least you need to do approximately 150 to 200 questions of KCL and KVL. And if we are able to do this, we can solve it at any point of time, because this is the topic that you need to prepare for once in class 12, and it will be with you throughout the class 12. You do not need to even revise it. So please do it. Thank you. Have a good day. Take care. Bye bye.